So suppose that I wanted to find a function of this matrix, 2 to the power 7, 5, -5, -3. As we've seen, one way to do this will be to diagonalize this matrix. So let's find the eigenvalues and eigenvectors. The sum of the eigenvalues of this matrix is 7 minus 3, which is 4. The product of the eigenvalues of this matrix is the determinant of the matrix, -21 plus 25, which is 4. The real numbers that sum to 4 and multiply also to 4 are 2 and 2. So therefore, we would say the only eigenvalue is 2. To find the eigenvectors associated with lambda equals 2, we'll subtract 2 times the identity from this matrix. We only get one linearly independent eigenvector, just one. So that means that this matrix is not diagonalizable. I cannot find 2 to the power of this matrix by diagonalizing it, doing 2 to the diagonal matrix, and then transforming back. However, we do know that as a result of the Cayley-Hamilton theorem, the characteristic polynomial of this matrix is lambda minus 2 squared. So that means A minus 2 times the identity squared is equal to the 0 matrix. And this opens up an avenue that we might not have even dreamed of before. Let's see what we can do with this. Just like that, now, why is that helpful? Well, when I take this squared, or any power of this higher than 2, it'll just be 0. And that immediately brings to mind a Taylor series expansion. Oh, didn't see that one coming, did you? So what we're going to do is we're going to rewrite this as e to the a minus 2 times the identity times the natural logarithm of 2. And then we'll use a Taylor series expansion for this exponential. The Taylor series for e to the something is 1 plus the something squared divided by 2 factorial plus the something cubed divided by 3 factorial, and so on and so forth. So I'll get 1 plus the something plus the something squared over 2 factorial plus on and on and on. But we said that a minus 2 times the identity squared was equal to 0. Such a matrix, a non-zero matrix, one of whose powers is 0, is called a nilpotent matrix. So that means that this is 0. And all the dot, 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 all that is just 0. So we have the identity, and then plus A minus 2 times the identity. Log 2, and we'll be done with it. So therefore, 2 to the power of this matrix is equal to 4 plus 20 log 2 minus 20 log 2, 20 log 2, and 4 minus 20 log 2. We can't verify that one as nicely as we can with the square root, but it's certainly surprising.